students, as we have seen that in concave mirror we were having 6 cases. So here we are having the ray diagram for the convex lenses, and in this case also we are having 6 sets. So let us go through it one by one. So case 1 is when the object is placed at infinity, same that we have done in the mirror case. So the light ray that is coming from the infinity, after refraction it is going to bend and it is going to meet at a single point. That is known as focus, because it is obviously, that is why we have kept the name here focus, and according to the length of the focus, this point till the optical center, and if we converge it like making it twice, O, F, and the distance between it, and twice again the distance, same distance from it, so we have called it as 2F. Okay, so accordingly the light rays that are coming parallel to the principal axis, you know that it all passes through the focus, and that is why it is known as focus, that is pinpoint size image. You might have seen the microscopes, okay, and microscopes diagrams you have seen, but magnifying glass, in a magnifying glass this kind of convex lens is used, that even I have done it in my childhood, that I used to put it like on the paper and providing all the sun rays and keeping it all on the focus at a single point, that makes it burn. So what is happening here, the light rays that is coming parallel, after refraction from the convex lens, it is going to meet all at one point. So we can say that all the energy that is coming parallel are meet at a single point. That is why the temperature here is going to increase and it makes it burn the paper. Okay, so here this was the practical example of this convex lens, but in theory, what you can hear, what you can remember, according to the exams, you can ask that what is the case when the object is placed at infinity. Draw the diagram for it. So this is how you are going to make it, by using the rules, the 3 rules that we have just seen in the previous slides. And here also you just use 2 slides, okay, 2 rules only at a time, so that making 2 rays, for making only 2 rays. So here, because this was the journal diagram, so I have made here a lot of rays, because the rays are coming from the infinity. So all these would be the parallel only. That is why it is focusing at one point. This is the case number 1. Let us see the next case, case number 2, when the object is at beyond 2F. Same as we have seen in mirror case, beyond 2F, then 2F, then closer, closer, closer. Okay, so from infinity we have just kept ourselves to the little closer, that we are standing here beyond 2F. Here AB is standing. So you can use any of the 2 rays. So now from head A we have just used 1 ray like this. It is going parallel, and after refraction it is going from the focus, passing through the focus point. And here 1 ray is coming from the passing through the optical center, and after passing directly without deviation it is passed through the optical center like this. So they will be met at a point. So wherever they are meeting, this would be the actual image. So meeting of the rays will give you the real image that they are actually meeting, and real image, you know, always be inverted image. So this would always be real and inverted. Now here the A is going to give you the A dash. Now the thing that we can see here, this is the larger in size and the image you are getting is little bit smaller. So we can say that here in this case, the larger image object would have the smaller image, but not diminished, but smaller in size compared to the object. Now let us move towards the case number 3, that the object is at 2F. Remember what happened when the image, in case of concave mirror, the object was at the center of curvature. So we were getting the same image but in real and inverted form, same size, at 2F only. So here also we are getting the object that is at 2f at this part, at this left side, and that is going to be making its image at the same side and same place with the same structure, same size. Now let us move towards the case number 4, when the object is between f and 2f. Now what is happening? F and 2f in between. So here rays are parallel and going from the focus, and this is again same structure you can use any after 2. Even you can do like this, that the light ray is passing from the focus and after refraction here it is going to be parallel. So again it is going to meet here only. So now this image, whatever we are getting for the object that is standing in between f and 2f, would be larger in size. Okay, see, this is more in size compared to the object, and again lights are actually meeting, so this would be real and inverted image. So this is the same thing that we have seen in the concave mirrors. Even that concave examples and convex lens examples are almost same here in this case. Now see case number 5, when the object is at f, that is the focus point. So when the object was at infinity, you were getting the image at focus. So now the object is at focus point, so where you are getting the image? The image, actually the light rays are going to be parallel, and these are going to be parallel for a long time. Parallel rays never met. So we pretend it like it is going to be made at the point that is at the infinity. So because these are parallel, so somewhere else they are going to meet. We don't know because it is beyond our limit. But the ray diagram for this case is going to be like this. Now let us going towards the case number 6. So here we are having when the object is in between O and F, that is optical center and the focus. Now you know that the ray is going to be parallel and after that passing through this and from the optical center going straightly, but these are diverging. So when these are diverging, that means they are not going to be meet. These are again and again extending like this. So if we are taking the back side of it and making an angle like this, if we are extending it at the back side of the object, so we will find that this would be the virtual image. Because it is sensing light, we are not capable of looking the light rays to be bending. So what it seems like, it imagines, our brain imagines that light is not going and bending itself in this manner, but actually the image is at the back side of us. That is why you are getting a very big magnifying image of yourself when you are standing in front of this convex lens.